14. Electric current and its effects. You might have tried the game How Steady Is Your Hand, suggested in chapter 12 of class 6. If not, you may try it out now. Paheli and Bojo had also set up the game by connecting an electric circuit as suggested in class 6. They had lots of fun trying it out with their families and friends. They enjoyed it so much that they decided to suggest it to a cousin of theirs who stayed in a different town. So Paheli made a neat drawing showing how the various electric components were to be connected. Figure. Figure set up to check how steady your hand is. Can you draw this circuit conveniently? It made Bojo wonder if there was an easier way to represent these electric components. 14.1 Symbols of electric components. Some common electric components can be represented by symbols in table. Some electric components and their symbols are shown. You may come across different symbols for these components in different books. However, in this book we shall be using the symbols shown here. Look at the symbols carefully. In the symbol for the electric cell, notice that there is a longer line and a shorter but thicker parallel line. Do you recall that an electric cell has a positive terminal and a negative terminal? In the symbol of the electric cell, the longer line represents the positive terminal and the thicker, shorter line represents the negative terminal. For a switch, the on position and the off position are represented by the symbols as shown. The wires used to connect the various components in a circuit are represented by lines. In table, a battery and its symbol are also shown. Do you know what a battery is? Look at the symbol of a battery. Can you make out what a battery could be? For some of the activities, we may need more than one cell. So we connect two or more cells together as shown in figure. Notice table symbols for some electric circuit components. Serial number, electric component, symbol, 1 electric cell. 2 electric bulb. 3 switch in on position. 4 switch is off position. 5 battery. 6 wire. That the positive terminal of one cell is connected to the negative terminal of the next cell. Such a combination of two or more cells is called a battery. Many devices such as torches, transistors, toys, TV remote controls use batteries. However, in some of these devices, the electric cells are not always placed one after the other as shown in figure. Sometimes the cells are placed side by side. Then how are the terminals of the cells connected? Look carefully inside the battery compartment of any device. There is usually a thick wire or a metal strip connecting the positive terminal of one cell to the negative terminal of the next cell. Figure. In order to help you to place the cells correctly in the battery compartment, plus and minus symbols are usually printed there. How can we connect the cells to prepare batteries for our activities? You may make a cell holder. As shown in figure, use a wooden block, 2 iron strips and rubber bands. It is necessary. Figure. A battery of 2 cells. B. A battery of 4 cells. Figure. Connecting 2 cells together to make a battery. Figure. A cell holder. Figure. Another type of cell holder. That the rubber bands hold the metal strips tightly. You could also buy cell holders from the market for making batteries of 2 or more electric cells. Place the cells in them properly such that the positive. Paheli and Bojo wonder whether the batteries used in tractors, trucks and inverters are also made from cells. Then why is it called a battery? Can you help them to find the answer to this question? Figure, truck battery and its cutout. Terminal of one cell is connected to the negative terminal of the next cell. Connect a piece of wire each to the two metal clips on the cell holder as shown in figure. Your battery is ready for use. The symbol used for representing a battery is shown in table. Let us now draw a circuit diagram of an electric circuit using symbols shown in table. Activity 14.1. Do this. Make an electric circuit shown in figure. You used a similar circuit in class 6 to make an electric bulb glow. Do you remember that the bulb glows only when the switch is in the on position? The bulb glows as soon as the switch is moved to the on position. Copy this electric circuit in your notebook. Make also a circuit diagram of this circuit using symbols for the various electric components. Is your diagram similar to the one shown in figure? It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram. Figure shows another circuit diagram. Is it identical to the circuit diagram shown in figure? In which ways is it different? Would the bulb glow in this electric circuit? Recall that the bulb glows only when the switch is in the on position and the electric circuit is closed. Figure and electric circuit. Figure, circuit diagram of electric circuit shown in figure. Notice that the key or switch can be placed anywhere in the circuit. When the switch is in the on position, the circuit from the positive terminal of the battery to the negative terminal is complete. The circuit is then said to be closed and the current flows throughout the circuit instantly. When the switch is in the off position, the current is incomplete. It is said to be open. No current flows through any part of the circuit. In the bulb there is a thin wire called the filament, which glows when an figure another circuit diagram. Electric current passes through it. When the bulb gets fused, its filament is broken. Caution: never touch a lighted electric bulb connected to the mains. It may be very hot and your hand may be burned badly. Do not experiment with the electric supply from the mains or a generator or an inverter. You may get an electric shock, which may be dangerous. Use only electric cell for all the activities suggested here. If the filament of the bulb is broken, would the circuit be complete? Would the bulb still glow? You might have noticed that a glowing electric bulb became warm. Do you know why? 14.2. Heating effect or electric current. Activity 14.2. Do this. Take an electric cell, a bulb, a switch, and connecting wires. Make an electric circuit as shown in figure. This activity has to be done using only one cell. Keep the switch in the off position. Does the bulb glow? Touch the bulb. Now move the electric switch to the on position and let the bulb glow for a minute or so. Again touch the bulb. Do you feel any difference? After moving the switch back to the off position, touch the bulb again. Activity 14.3. Do this. Make a circuit as shown in figure 14.10. Take about 10 cm long piece of nichrome wire and tie it between the nails. You can get nichrome wire from an electric repair shop, or you can use a piece of discarded coil of an electric heater. Touch the wire. Now switch on the current in the circuit by moving the switch to the on position. After a few, figure. Caution: do not keep the switch in the on position for a long time. Otherwise the cell may become weak very quickly. Seconds, touch the wire. Do not hold it for a long time. Switch off the current. Touch the wire again after a few minutes. The wire gets hot when an electric current passes through it. This is the heating effect of the electric current. Can you think of any electric appliance where the heating effect of the electric current is used? Make a list of such appliances. You might have seen an electric room heater or an electric heater used for cooking. All these contain a coil of wire. This coil of wire is called an element. You may have noticed that when these appliances are switched on, Bojo could not see element in an electric iron. Paheli told him that electrical appliances such as immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers have elements inside them. Have you ever seen the element in any appliance? Figure element of electric iron. Figure glowing filament of an electric bulb. Incandescence. After connecting to the electric supply, their elements become red hot and give out heat. The amount of heat produced in a wire depends on its material length and thickness. Thus, for different requirements, the wires of different materials and different length and thickness are used. The wires used for making electric circuit do not normally become hot. On the other hand, the elements of some electric appliances become so hot that they are easily visible. The filament of incandescent electric bulbs figure are often used for lighting, but they also give heat. It means that a part of electricity consumed is used in producing heat. This is not desirable as it results in the wastage of electricity. The fluorescent tube lights and compact fluorescent lamps (CFLs) are better electricity efficient lighting sources. Nowadays, the use of light emitting diode LED bulb is increasing. For producing a given intensity of light, LED bulbs consume less electricity as compared to incandescent bulb or fluorescent tubes or CFLs. Thus, LED bulbs are much electricity efficient and therefore being preferred. Figure electric bulb, tube light, CFL and LED. It is advised to use electrical appliances and gadgets which are electricity efficient. Bureau of Indian Standards, New Delhi assigns a standard mark on products called ISI mark, which is an assurance of conformity to the specifications given on the production. It is therefore suggested to use ISI mark products. Note: fluorescent tubes and CFLs contain mercury vapor, toxic in nature. Therefore, damaged fluorescent tubes or CFLs need to be disposed of safely. Figure fused use in buildings. An electric bulb gets heated to such a high temperature that it starts glowing. If a large current passes through a wire, the wire may become so hot that it may even melt and break. But is it possible for a wire to melt and break? Let us check it out. Activity 14.4. Make the circuit we use for activity. Again, however, replace the cell with a battery of 4 cells. Also, in place of the nichrome wire, tie a thin strands of steel wool. The steel wool is commonly used for cleaning utensils and is available in grocery shops. If there are any fans in the room, switch them off. Now pass the current through the circuit for some time. Observe the strand of steel wool carefully. Note what happens. Thus, the strand of steel will melt and break. Wires made from some special materials melt quickly and break when large electricity current is passed through them. These wires are used for making electric fuses. Figure in all. Figure fuses used in electrical appliances. Buildings fuses are inserted in all electrical circuits. There is a maximum limit on the current which can safely flow through a circuit. If by accident the current exceeded this safe limit, the wires. Caution: never try to investigate an electric fuse connected to main circuit on your own. You may, however, visit an electric repair shop and compare the burnt out fuses with the new ones. One reason for excessive currents in electrical circuits is the direct touching of wires. This may happen if the insulation on the wires has come off due to wear and tear. This may cause a short circuit. Another reason for excessive current can be the connection of many devices to a single socket. This may cause overload in the circuit. You might have read report in newspaper about fires caused by short circuit and overloads. May become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow up and break the circuit. A fuse is thus a safety device which these days miniature circuit breakers MCBs are increasingly being used in place of fuses. These are switches which automatically turn off when current in a circuit exceeded the safe limit. You turn them on and the circuit is once again complete. Look for ISI mark on MCBs also. Figure Miniature Circuit Breaker MCB. Caution: always use proper fuses which have been specified for particular applications carrying ISI mark. Never use just any wire or strip of metal in place of a fuse. Prevent damages to electrical circuits and possible fires. Fuses of different kinds are used for different purposes. Figure shows fuses used in our houses. Fuses shown in figure are generally used in electrical appliances. We observed the heating effect of the electrical current and learned how we use it to our advantage. Does the electric current have other effects also? 14.3 Magnetic effect or electric current. Activity 14.5. Do this. Take the cardboard tray from inside a discarded matchbox. Wrap an electric figure effect of current on a compass needle. Write a few times around the cardboard tray. Place a small compass needle inside it. Now connect the free ends of this wire to an electric cell through a switch as shown in figure. Note the direction in which the compass needle is pointing. Bring a bar magnet near the compass needle. Observe what happens. Now while watching the compass needle carefully, move the switch to the on position. Figure Hans Christian Ørsted, AD 1777 to 1851. What do you observe? Does the compass needle deflect? Move the switch back to the off position. Does the compass needle come back to its initial position? Repeat the experiment a few times. What does this experiment indicate? We know that the needle of a compass is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that compass needle gets deflected when the current flows in a nearby wire. Can you connect the two observations? When the current flows through a wire, does the wire behave like a magnet? This is what a scientist called Hans Christian Ørsted figure also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. Do you find it too surprising? Let us try it out. Figure an electromagnet. Remember not to switch on the current for more than a few seconds at a time. The electromagnet weakens the cell quickly if left connected. 14.4 Electromagnet activity. 14.6 do this. Take around 75 cm long piece of insulated plastic or cloth covered or enameled flexible wire and an iron nail, say about 6 to 10 cm long. Wind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell through a switch as shown in figure. Place some pins on or near the end of the nail. Now switch on the current. What happens? Do the pins cling to the tip of the nail? Switch off the current. Are the pins still clinging to the end of the nail? The coil in the above activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy loads. Do you remember the crane about which you read in chapter 13 of class 6? The end of such a crane has a strong electromagnet attached to it. The electromagnets are also used to separate magnetic material from the junk. Doctors use tiny electromagnets to take out small pieces of magnetic materials that have accidentally fallen in the eye. Many toys also have electromagnets inside them. 14.5 Electric bell. We are quite familiar with an electric bell. It has an electromagnet in it. Let us see how it works. Figure shows the circuit of an electric bell. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to. Figure circuit of an electric bell. The electromagnet, there is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil which becomes an electromagnet. It then pulls the iron strip. In the process, the hammer at the end of the strip strikes the going of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. Will the coil remain an electromagnet? The coil is no longer an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quick succession. The hammer strikes the gong every time the circuit is completed. This is how the bell rings. Keywords: battery, circuit diagram, electric components, electric bell, electromagnet, fuse, heating effect of current, magnetic effect of current. What you have learnt? It is convenient to represent electric components by symbols. Using this, an electric circuit can be represented by a circuit diagram. When an electric current flows through a wire, the wire gets heated. It is the heating effect of current. This effect has many applications. Wires made from some special materials melt quickly and break when large electric currents are passed through them. These materials are used for making electric fuses, which prevent fires and damage to electric appliances. When an electric current flows through a wire, it behaves like a magnet. A current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. Electromagnets are used in many devices. Exercises. Do this and comment this. Figure, 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 figure. Extended learning activities and projects. Do this and comment this. Paheli and Bojo saw a magic trick some time back. The magician placed an iron box on a stand. He then called Bojo and asked him to lift the box. Bojo could easily lift the box. Now the magician made a show of moving his stick around the box while muttering something. He again asked Bojo to lift the box. This time Bojo could not even move it. The magician again muttered something and now Bojo could lift the box. The audience, including Paheli and Bojo, were very impressed with the show and felt that the magician had some supernatural powers. However, after reading this chapter, Paheli is wondering if the trick was indeed some magic or some science was involved. Can you guess what science might be involved? Figure a working model of a railway signal. Cardboard signal, thread, iron nail, coil. Do this and comment this. Did you know? The credit for the invention of the electric bulb is usually given to Thomas Alva Edison, though others before him had worked on it. Edison was a remarkable man. He made some 1300 inventions, including the electric bulb, gramophone, the motion picture camera, and the carbon transmitter, which facilitated the invention of the telephone. Figure Thomas Alva Edison, AD 1847 to 1931,